explain how to name alkanes, alkynes, and alkenes according to the UPAC's nomenclature. And also, we're going to talk about hydrocarbons and its importance in our world. We hope you like it. And I'm Paola, and I'm going to give a little introduction about organic chemistry and UPAC. UPAC stands for International Union of Pure and Applied Chemistry. It's a non-governmental organization created in 1919 for 1,200 chemists around all the world to name organic compounds. UPAC gives names, symbols, and units to all the organic compounds. The predecessor of UPAC, the International Association of Chemical Societies, met
I'm Bjorn, and I'm going to talk about hydrocarbons in general. Hydrocarbons are the simplest organic compounds that we have, containing only carbon and hydrogen. They can be straight chain branched or cyclic. Carbon tends to have a tetrahedral geometry, which means tetra means 4 and hedral means the number of sides that it has. There are many groups. The first one is the alkanes, that has single bonds. Second is the alkenes, containing double bonds. The third one is alkynes, which has triple bonds. There is also the cyclic, and the aromatic.
My name is Diego Marquez, and now I'm going to talk about alkanes. In order to understand this topic, first we need to think that our hydrocarbons are bracelet, and then every bracelet has some rods attached to it. These rods will also be known as substance or alkyl groups. So now we are going to be talking about how to name alkanes. So here's an example. first step when naming alkanes is we have to look for the longest chain. The longest chain will be our bracelet when compared to the hydrocarbons. The hydrocarbons have to be always linear and with no branches on their sides. So we start counting from the edge from edge. 1, 2, 3, 4, and 5. We can look for other options like 1, 2, 3, or 4, but that will be not our longest chain. So we start. That will be our longest chain. Now we will look for substituents. The substituent will play the role as the rocks of our bracelet and are the branches attached to the main bracelet. In this case, we have this one. Now we have to count the number of carbons. The side where we start depends on where the branch of the hydrocarbon is. For example, the closest to the branch will be the first one. So in this example, the hydrocarbon is placed in this position. So from here we have 1, 2, and this will be our third hydrocarbon. And from here, this will be 1, 2, and this will be our third hydrocarbon. So in this specific case, it's the same from where do we start. So we start from here, and we count the hydrocarbons. Okay. Now that our hydrocarbon is already numbered, we need to determine in which carbon our alkyl group is. In this case, our alkyl group is placed at carbon number 3. So now we have to identify what type of branch or what type of alkyl group we are talking about. According to UPAC, the name of the alkyl group is specified by the number of carbons in it. So in this case, we only have one carbon. Since it is an alkyl group, its ending, it ends with the YL. And the amount of carbons tells us that it's a methane. Meth stands for one carbon. So we join these two, and we can add meth as our final alkyl group. So our last step will be determine the alkyl group. Now, to give the final name to the compound, we need to determine how many carbons do we have in the primary chain. In the primary chain, we have 5 total carbons. So our name will start with pen. Pen stands for 5 carbons. So now we need to identify if we are talking about an alkene, an alkyne, or an alkyl. We can't identify any type of double bonding or triple bonding. So in this case, we are talking about an alkane. Alkane ends with suffix "ane". So we will pass the suffix to prefix "pent" to form pentane. Now, this will be the name of our primary chain, and we will add the name of the alkyl. The alkyl group is at number 3, at carbon number 3. So we have 3 dash methyl and then we add the number of the primary chain that will be 20. Okay, so now that we already understood how to make alkanes, we're going to talk about examples. First, imagine that the instruction given is first, we're going to start with an easy example. First, our first step is to identify how many carbons we are asked to draw. So in this case, we're looking for the prefix pent. Pent starts for 5. So in this case, we're going to make our change of high carbons. Now that we already have our chain, we need to look for alkyl groups. In this case, we don't have any. So our final step here will be to saturate our compound with using hydrogens. So as we already know, carbon has 4 covalent bonds. This means that it should have 4 joints between each carbon and each hydrogen. So in this case, since carbon has only 1, we should saturate using 3 other hydrogens. In this case, carbon has 2. So we should saturate using another 2. The same happens here. The same happens here. And finally, we have the last carbon that only has one joint. So we add another 3. So here we are with our second example. In this case, this example may be a little tricky, since we'll think that our longest chain will be this one, but we are wrong. If we count carefully, we can identify that this chain is a little bit longer, since we have 1, 2, 3, 4, and 5. We have no branches, and this will work as our longest chain. So the first step is to identify the longest chain, and in this case will be this one. Now that we already have our identified, we'll look for the branches or the alkyl groups. In this case, we got these 2. Now, the third step is to number up the chain of carbons. In this case, we have starting from edge to edge. We will start from this side, since our alkyl group is closer to this one than this alkyl group to the first carbon. So we'll start 1, 2, 3, 4, and 5. Our last step is to check for the alkyl groups. In this case, we have an alkyl group of methyl, since it has only 1 carbon on the second carbon and another one in the third carbon. So our compound will have number 2 carbon and 3 carbon, D because we have 2 methyl, and since we don't have any double bonding on the compound, and our compound is made of 5 carbons, will be pentane.
Alkenes and alkynes. What is an alkene? An alkene is an organic compound, unsaturated, that contains at least one double bond between carbons. What is an alkyne? An alkyne is another organic compound that contains at least one triple bond between each carbon. For naming an alkyne, there are some rules. The first one is choose the correct ending. For alkenes, this is in, and for alkynes, this is ein. The second step is to determine the longest chain of carbons and circle it. Where a double or triple bond is present, choose the longest chain that includes this bond. Okay. The third step is to number each carbon in the parent chain. The fourth step is to observe the branches and cite the name alkyl substituent before the name of the parent hydrocarbon. The fifth step is that is if the same alkyl group occurs more than once as a branch on the parent structure, use a prefix D for 2, 3 for 3, and tetra for 4. Okay? Before its name to indicate how many times it's appeared. The sixth step is when different alkyl groups are attached to the same parent structure, place their names in alphabetical order. Do not consider the prefix when determining alphabetical order. The seventh step and the last one is write the entire name using hyphens to separate numbers from words.